Hello! We are doing number 10.1. And this describes a rather unlikely situation. Imagine that you're out in space and there's your spacesuit. You know, there you are with your helmet out there and you're out there in space. But there's a problem. You're not in there. You are back on the space station and you're out there looking at the situation and you're going, oh no, my spacesuit is out in space and I'm not in it. And then to make matters worse, it springs a leak. And all the air starts going out of your spacesuit like a leaky balloon. So you're gonna go off, your spacesuit's gonna go off, and the question is, with how much energy is going to be released by your deflating spacesuit as you are helpless to do anything other than stand there and watch? Well, we have a formula for that. We always do. And here's our formula. So the work of a reaction, work is equal to pressure times the change in volume. So your spacesuits are actually not inflated to full atmospheric volume, which would be 101.3 kilopascals. They're actually inflated to about half that. And one of the reasons why is, you think about it, you're all inflated up there. You're always having to fight with your suit in order to get it to bend. The more pressure, the harder you have to work. So they have it inflated about half regular atmospheric pressure, which allows a person to move around without giving them the bends or having them lightheaded because they don't get enough oxygen. So we have given you a number for the pressure of 5,000 or 50,000, 50 kilopascals, 700 pascals, not kilopascals, pascals, 50,000 pascals, which is 50 kilopascals. Work will equal that. And the change in volume. Well, from chapter 8, you have your volume. Now, I have a volume of 109 liters. But, that is not the form you should put it in, because, Pascal stands in for force. But if you'll remember, the pressure is, a Pascal is force per square meter. So you're actually dealing with cubic meters. You're not dealing with liters. We're used to thinking of volume in liters, but in this case we're doing volume in cubic meters. So I'm not 109 liters, I'm 0.109 meters cubed. So it's a fairly simple and straightforward equation. You punch that in the calculator, I punched in there, and I got 5,526.3 joules of work, which is not an enormous amount, although you're not dealing with an enormous volume and you're dealing with a very small pressure. In fact, the pressure is so small you would never find it down here on the surface. One thing to think about, 3 sig figs, rounded to 3 sig figs, 5,530 joules should be your answer. What could you do with that much energy? If you're me, you could climb a set of stairs to the next story. Not a lot, really. You really couldn't do very much. But, they don't inflate these things to be like rockets. It's a spacesuit. Anyway, there you are. I hope we're able to find that spacesuit. Hope we can fix it too.